Hello everyone, and welcome to Math 126 Online. This is our first section, which is section 1.1. My name is Philip Cook. I will be creating these lectures with the help of my wife and colleague, Ayla Cook. We hope you guys enjoy, okay? And so let's go ahead and get started. So, section 1.1 is our first section, which is the rectangular coordinate system, which we probably have a little bit of knowledge about. So the main things we want to study in this video are the distance formula and the midpoint formulas. So I like to start this off by asking a motivation question. What is the linear distance? I'm going to put linear in parentheses because it's implied when you say distance, but if we want to be mathematically pompous, I guess, we can add that in. So what is the linear distance? That's terrible distance. Distance and midpoint between the point -2, 1 and the point 1, 5. So what is the linear distance and where is the midpoint between these two things? Now you might think this is completely arbitrary and not useful at all, but I'll try and remind you guys about this, is that in real life, you can kind of compose a grid you can impose a coordinate system on your location, and you can use that to figure out distances. So naturally, this has a very important use. So let's go ahead and try and figure this out. That is to say, how do we figure this out? How do we create a mathematical model to figure this out? So, on this page, you'll notice that I've already plotted our 2 points. So -2, 1. So you start from the origin, move left 2, and then up 1. So your x coordinate is -2, y coordinate is 1. Similarly, for 1, 5, that's x is 1, y is 5 right there. Now, I've drawn this red line here, and that right there, that is the distance that we want to compute. And then in addition to that, we'll have this little blue, why not blue? We'll have this little point right about here, and that's the midpoint between these two things. I mean, it's an eyeball, right? Like, it's not perfect, and we'll find it out soon enough. But those are the two things I want to find. Now, they're found differently. So for distance, let's start with that. For distance, how would we figure out what this distance is? Now, this is where mathematicians kind of become a little bit clever. So I'm going to kind of denote this right here. If you were to create a triangle, let me use dark green here. If you were to create a triangle, that's a right triangle in particular, then we know about the Pythagorean theorem, right? So we could calculate this side length and this side length, and then we could use the Pythagorean theorem to find the hypotenuse, which is the distance here. So that's what we're going to do. Use the Pythagorean, and I'm just going to abbreviate that Pythag theorem, which is, if you remember, it's a squared plus b squared equals c squared. That's the general way we usually call it, where a and b are the legs and c is the hypotenuse. It's very important as a reminder that a squared plus b squared, those are the legs squared, equals the hypotenuse squared. So here, let's just call that distance capital D for now, right? Capital D is equal to, well, what's this distance? Well, I mean, we could count it. 1, 2, 3. That's a distance of 3 units. So let me write that down. So this right here is 3 units, and this right here, if we count that, that's going to be 4 units. So this is going to be 3 squared plus 4 squared. Oh, and that should be a d squared, my apologies. The distance squared, because that's the hypotenuse. Oop. That's the hypotenuse right there, which we're going to call capital D. So that would give us that d squared is equal to 9 plus 16, which would be 25. Take the square root of both sides, And remember, if you take the square root of both sides, you have to add the plus or the minus. However, we're talking about length. We're talking about a distance, and distance is intrinsically a positive idea. We can't go negative 5 feet or whatever, right? We can't travel negative 5 feet. So the minus sign in this context is unnecessary. So we'll just say, let's kind of make a point there. Say, distance can't be negative. Which means that capital D is 5 units. That's the distance from the point negative 2, 1 to 1, 5. And I know that seems kind of random to bring up this whole plus or minus square root thing, but I just wanted to bring it as a refresher that if you use the square root property, i.e. take the square root of both sides, you need to put that plus or minus. The reason why we get rid of the minus in this case is because in the context of our problem, we're not dealing with negative numbers because we're talking about distance. Anyways, so that's the distance. For the midpoint in this situation, that's a little bit trickier because how do we eyeball that point? Well, think about the x values and the y values of this thing. By definition, since it's the middle point, that means that it should have the x value that's in between negative 2 and 1, and the y value that's in between 1 and 5. And so that's what I'm going to write. If we find the middle of the x values and the middle of the y values, that will give it the midpoint. So, in this context, that would mean that the middle x, well, we'll take negative 2 plus 1 and divide that by 2. We're trying to find an average. So negative 2 plus 1 divided by 2 gives me negative 1/2. So just as a small aside while I've got you here, the reason why this is the formula is we want to find the average between these two things. So we've got the number, like the middle of it will be the average between these two numbers. So if you add them together and divide by 2, we will get the middle. That's negative 1/2, and then the middle y, done similarly, is going to be 1 plus 5 over 2, which will be 3. That's not our answer, though, because remember, we're looking for a midpoint, right? So we got to write this as an ordered pair. So the x-coordinate was negative 1/2, and the y-coordinate was 3. And I did a pretty good job if you look at it. So like it's roughly on the 3, and maybe it's like 1/3, but whatever. I did pretty good. So, yeah, that's how to find the distance and midpoint for this specific thing. But I asked this question: what if these were? This was just negative 2, 1 and 1, 5. What if these were arbitrary points? What if we wanted to be able to figure out the distance and midpoint for any set of points, right? Well, let's go ahead and figure that out. So, the distance and midpoint formulas, right? So, given 2 points, these are like, and notice that I'm saying 2 points. I'm not specifying what they are. So we're going to assume that they're arbitrary. Let's call one of them x sub 1, y sub 1, and the second point x sub 2, y sub 2. These could be any points in our Cartesian grid, our rectangular coordinate system. Then, that's a terrible then, sorry. Then, we have 2 formulas. The distance formula, which is going to be d. We usually use lowercase d, but you can use a capital D, whatever you want to do. Let your channel your inner Bob Ross. But the distance is going to be the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That is the distance formula. And the midpoint formula is, I'm going to denote it capital M to mean the point, the midpoint is going to be x sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2. That is going to be the midpoint of the 2 points x sub 1, y sub 1, and x sub 2, y sub 2. So notice that the distance formula gives you a number because it's going to square root this and give you a number, and the midpoint is an actual point. So why does this work? Well, I mean, like, if you're curious, I'm gonna go over it, but you can definitely skip ahead if you want. But if you're curious, I'd encourage it. So let's just try and extrapolate this. So we had this picture right here to get us through. So let's just pick two random arbitrary points, which we're going to call x1 and y1. So it doesn't really matter where you place them. I'm just going to put x sub 1, y sub 1 right there. And then I'm going to put x sub 2, y sub 2 right there. And once again, it doesn't matter. And so we're trying to figure out this distance right here. We're going to call that d, or lowercase d or uppercase d, doesn't matter. And then we also want to find the midpoint, which is roughly about there, right? So this is a very classic thing mathematicians do, and I hope you try and work it into your skill set as a mathematician. Is sometimes we look at specific examples to draw inspiration to how to figure out how to generalize it. So what I'm going to do is the same thing. In particular, I'm going to impose a little triangle down bottom, and then here's the other leg. And the question is, what is this distance? What is this distance? Right? Don't write the question mark. So, if you think about it, this distance down here, all the way up to here, that is x sub 2. Don't write this. Just watch. So, starting from 0, this distance here, that's x sub 2. And this is x sub 1. That's the distance, that's a distance of x sub 1. And this is a distance of x sub 2. If we want to know this blue length, we just take the difference, right? This is the bigger one, and we're going to just subtract off this little one. In fact, it's what we did right here. 1 minus negative 2 gives you positive 3, right? Subtracting negative means adding it. Whoa, right? So, in particular, let's erase this and say that this is going to be x sub 2 minus x sub 1. In addition, this distance is going to be y sub 2 minus y sub 1. So, that gives us the formula, right? D squared is equal to x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 squared, which gives us the formula when we take the square root of both sides and we ignore the minus sign. Like, we do the plus or minus, but we ignore the minus because it's a distance, and you get the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that's the distance formula. Now for the midpoint, we want to find the middle of these two x values, and so that's exactly what it is. So we take this x value 1. So for the midpoint, I'm going to use blue, sorry. So for the midpoint, we're going to take the average of the x's, comma, the average of the y's. So that'll be x sub 1 plus x sub 2 averaged, and y sub 1 plus y sub 2 averaged. And there we have it. Well, I don't need to box it. That's it. So that's how these formulas come to be. If you have any questions, please feel free to ask about it. We love talking about the generalizations of these things. So now that we got that out of the way, let's actually do some practice. Let's put this to the test, okay? So, example. Find the distance and midpoint of part A will be negative 2 comma 4 and 1 comma 6, and part B will be 0 comma negative 2 and 6, 6. That's right. All right. So let's go ahead and get started. Solution. So for part A, I'm going to draw this for right now, but you don't have to if you don't want to. So right here, this is my x sub 1, and this is my y sub 1, and this is my x sub 2, and this is my y sub 2. That's my first point, and this is my second point. Now, I want you to think about this for a second. Does the order matter? Pause and think about it for a second. But the answer is no, it doesn't matter. I could have just as easily made this my first point, like i.e. my x sub 1, y sub 1, and this my x sub 2, y sub 2. It doesn't matter. And if you're curious about that, feel free to talk to us, right? There's a very, very cool reason why it works mathematically and also like just arithmetically. But anyways, so capital D is equal to the square root, and you don't have to rewrite the formula, but I like to do it because it helps me memorize it. So it's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And just following right along, that'll be the square root of x sub 2, which is 1, minus negative 2, which would be plus 2 squared. And then it'll be y sub 2, which is 6, minus 4 squared, which ends up being the square root of 3 squared plus 2 squared, which is the square root of 13. Now, if the problem asks for it to be an approximation, you'll want to round and you'll plug this into your calculator. Otherwise, just leave it as is. Just leave it as a square root, or simplify if it's nice, like you're going to see in the next problem in part B. But that's the distance, and then the midpoint is going to be x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2, which in this case would be x sub 1 would be negative 2 plus x sub 2, which is 1, divide that by 2, and then y sub 1 is 4, y sub 2 is 6, so 4 plus 6 divided by 2, which gives me negative 1/2, comma, 5. And that is my midpoint. As a small note that I decided to also just include right here for a moment, I do want to draw attention to it, not to confuse you, but to tell you of a very easy mistake that to make. This is x sub 2 minus x sub 1, y sub 2 minus y sub 1. This is x sub 1 plus x sub 2. It's very, very easy to get that mistaken. And another very easy thing is to want to do x sub 1 plus y sub 1. That also is not going to work. The formula is the x coordinates averaged, comma, the y coordinates averaged. So just I don't want you to make that mistake. But if you're getting the problem wrong, that might be what you're doing. So make sure you got the formula written down right when you're doing the problems. Anyways, let's do part B as well. Now this time I'm not going to write the formula, but you're more than welcome to if you'd like. And also, what I'd actually like you to do is I'd encourage you to pause the video and try this for yourself first, and then press play and make sure you got it right. But anyways, I'm going to continue onward because I'm assuming you're coming back from stopping. Anyways, so in this case, your x sub 1, y sub 1 is this point, and x sub 2, y sub 2 is that point. I encourage you, by the way, if you have a chance, if you're bored this weekend and have nothing to do, just flip up the points and see if you get the same answer. I guarantee you will. So, x sub 2 minus x sub 1, that's 6 minus 0 squared, plus y sub 2, which is 6, minus negative 2, which is plus 2, minus a negative makes it a plus. That'll be the square root of 6 squared. I'm going to put that over here. The square root of 6 squared, which is 36, and the square root of 8, which is 64. That's the square root of 100, and that's something we can simplify. 100 is a perfect square, and it equals 10. So the distance between these 2 points is 10. The midpoint is going to be x sub 1 plus x sub 2, so 0 plus 6 divided by 2. And then the y coordinate is going to be 6 plus negative 2 divided by 2, which would be 3, comma, and then this is going to be 4 divided by 2, which would be 2. And that is our midpoint. All right, so technically that completes this lecture for sections 1.1. But what I want to let you guys know about is something that we're planning to do for these lectures. is we're planning to make sure that these lectures have a lecture portion like you just saw, and then at the end of them, there are some extra practice problems if you want to stick around. So if you feel comfortable after watching these two examples and saying like, yeah, I got this, let's go ahead and get to it, be my guest. But if you want a little more practice and some fun problems, honestly, like a good Friday night stuff, feel free to stick around. So that's what we're going to do next. In particular, I've got this page of extra practice. 3 problems. So one of them kind of like what we did before, and then 2 kind of interesting extra practice problems. So go ahead and pause it and write them down if you want. But we're going to go ahead and get started right away with question 1, which is find the distance and the midpoint of these 2 points. So it doesn't matter which one you make your x sub 1, y sub 1, and your x sub 2, y sub 2. Convention would be this is your x sub 1, y sub 1, this is your x sub 2, y sub 2. So distance is going to be the square root of the differences of the x coordinates. So 6 minus negative 4, which would be 6 plus 4 squared, and 2 minus negative 3, so 2 plus 3, 20 squared. That's the square root of 10 squared plus 5 squared, which is the square root of 125, and that is our answer. We could simplify it down, honestly. If we wanted to get really technical, that could be 5 square root 5 if you want to simplify your radical. But I'm fine with this. I don't really need us to simplify radicals. We already did that in Math 96 and stuff, in algebra. We're in pre-calculus now. So that's the distance. And then the midpoint would be the average of the x-coordinates and the average of the y-coordinates. So negative 4 plus 6 over 2, negative 3 plus 2 over 2, which would be 1 comma negative 1/2. And that is your midpoint. And that's question 1. Bing, bang, done. And we move on to question 2. So show that the points A, negative 6 comma 3, 3 comma negative 5, and negative 1 comma 5 form a right triangle. Now this one's really tricky when you think about it. And it looks really intimidating because like Phil, we've never seen anything like this. It must be impossible. Well, no. When you run into a situation that you don't know in mathematics, my biggest suggestion is to say, well, what do you know? Like what topics in this question do we know about? And so the thing is, what do we know about right triangles? So we know right triangles satisfy the Pythagorean theorem, right? A squared plus b squared is equal to c squared, where a and b are the short legs and c is the hypotenuse. Now, don't get these a, b, and c's confused with these a, b, and c's. These are points, these are just values. So we know that right triangles have to satisfy the Pythagorean theorem, right? And in fact, right triangles are the only triangles that satisfy the Pythagorean theorem. So what we could do is we could find all these lengths, the length of AB, the length of AC, and the length of BC. If those legs satisfy, like if all those side lengths satisfy the Pythagorean theorem, then we know it's a right triangle. That means we need to calculate 3 distances. We need to calculate the distance of AB, the distance of AC, and the distance of BC. So let's just go ahead and compute those. So A and B, this one, in this, so when we're computing this, this is our x sub 1, y sub 1, this is our x sub 2, y sub 2. So that would be 3 plus 6 squared, because it's 3 minus negative 6, that's why it's plus 6, and then negative 5 minus 3 squared. That would be the square root, and now I'm going to stop the simplifications. This is 9, and this is negative 8 quantity squared, so that's going to be the square root of 145. And we'll just leave that as is. We don't need to simplify it. And by the way, feel free to use your calculators here to simplify this stuff. I could care less. I couldn't care less. So D, A, and C. This case, this is your x sub 1, y sub 1. This is your x sub 2, y sub 2. So that'll be negative 1 plus 6, right? Negative 1 minus negative 6 and then squared, and then 5 minus 3 quantity squared, which would be the square root of 29. And then we'll do BC, which would be the square root here. Now B is my x sub 1, y sub 1, and C is my x sub 2, y sub 2. So I'll get negative 1 minus 3 squared, right? X sub 2 minus x sub 1 plus y sub 2 minus y sub 1, so 5 minus negative 5, which would be 5 plus 5, right? Squared, which will be the square root of 116. Okay, so those are all of our side lengths. Now, you might be asking yourself, well, how do I know which one goes, like, if we're thinking about the Pythagorean theorem, the order matters, right? A and B are the legs, the shorter ones, and C is the hypotenuse. It's the longer one. I kind of gave away the hint here, but how do we know which one's the hypotenuse? We're trying to show that it's a right triangle. So this should, one of them should be our hypotenuse and the other two should be legs. So our proposed hypotenuse, it should be the longest side. This is the longest side, right? Because square root of 145 is going to be the biggest number. And these are going to be the, so that means this is the hypotenuse. And then these two are going to be the legs. Now we want to show that it satisfies the quadratic formula. So, does the square root of 29 squared plus the square root of 116 squared, does that equal? I like to put a question mark over my equal sign. So I'm not saying that these things are equal. I'm wondering if they're equal. Does that equal the square root of 145 squared? Well, that'll just be the square root and the square cancel, both on all three times. You got 29 plus 116 is 145. So we get, if we simplify this, we get 145 equals 145. And we get to put a check mark and say yes. So since it's we got a true statement, that means that, since we got a true statement, it means that these two legs and this hypotenuse satisfy the quadratic, or the Pythagorean theorem, which means that it's a right triangle. So we can write that in words. Since the side lengths satisfy the Pythagorean theorem, we have a right triangle. There we go. Very, very strange problem, but kind of cool. And you might be thinking to yourself, well, what I could just plot this into a computer. And then my old mathematician brain says, well, what if you didn't have a computer, right? But more specifically, even if you tried to draw this by hand, you wouldn't necessarily be able to convince, if you didn't scale it right, you might not be able to verify it just by look alone. You'd have to use math. You'd have to use this stuff. So we'll move on to last problem, question 3, which is the midpoint of a line segment from P1 to P2 is 5, negative 4. If P sub 2 is equal to 7, negative 2, what is P sub 1? Now this is a really cool problem. I absolutely love this problem. So let's try and parse through the information here. What is the question asking? It's asking us to find P sub 1. This means right here, if P sub 1 was some unknown point, x, we don't know what it is. We don't know what it is. It doesn't give it to us. So let's just call it something. Let's call it x sub 1, y sub 1. And we want to find these. These x and y values. That's what we want to do. Now, how will I get there? Well, there must be something given in the problem that gives me enough of the information. They tell us that this is the midpoint. So m is 5, negative 4, right? But we also know that the midpoint is x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. Meaning that the x-coordinate, this x-coordinate 5 has to be equal to the formula, right? So this means that x sub 1 plus x sub 2 Sorry about that. My stylus died. So x of 1 plus x of 2 over 2 is equal to 5. And y sub 1 plus y sub 2 over 2 is equal to negative 4. And you may be thinking to yourself, well, Phil, that's two variables. You can't solve for one. But we already know one of them, right? This right here is x sub 1, y sub 1. Or sorry, blah, 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 blah. I'm going to use a different color too. I'm going to use green. Why not? This is my point x sub 2, y sub 2. We know what the values of x sub 2 and y sub 2 are. In particular, we've got x sub 1, our unknown, plus 7 divided by 2 is equal to 5. And we've got y sub 1 plus negative 2 over 2 is equal to negative 4. And these are nice linear equations. We can just multiply both sides by 2 to get x plus 7 is equal to 10, which gives us x sub 1, rather. X sub 1 is equal to 3. So subtract 7 from both sides, you get x sub 1 is equal to 3. Similarly here, you get y sub 1 minus 2 is equal to negative 8. And once again, I'm getting that because I multiply both sides of this equation by 2. 2 times negative 4 is negative 8. And then plus a negative 2, that's the same thing as minusing a 2. So you get y sub 1 is equal to negative 6, which gives us that p sub 1, our first point, was 3 comma negative 6. And you can verify that when you take this point and you use the midpoint formula, you will get 5 comma negative 4. So that'll about do it for this lecture. I hope you guys liked it, and I will see you on the next one. All right, hi guys, have a great day.